Hello everyone, FunshineX here. This is another ComputerCraft tutorial. This is kind of a, I don't know, demo tutorial, show off kind of thing. If you just watched my 1500 subscriber special, you saw me showing off Connect4 in ComputerCraft. This game is part of the Connect4 arcade, which is pretty sparse right now. It only has Breakout, which you've seen before. If you haven't, go check my channel out. I think that was like, what, the 150 subscriber special? So I haven't worked on this in quite a while, but after messing around with CCGPU, which is a peripheral add-on for ComputerCraft, I'm like, I can draw circles really easy. Hey, these circles kind of look like chips in a Connect4 board. And yeah, so this was born. If you've been watching my Twitch stream, Twitch TV/FunshineX, you saw me build some of this live. So if you want to see me build this kind of thing, and you have some time late at night, because usually it's about 11 or midnight Pacific time, then hop on my channel. Again, it's Twitch TV/FunshineX. Just give me a follow or subscribe, whatever it's called on Twitch, and it'll send you an email whenever I go live, and you can watch me build this and other games that I'm going to be building in the ComputerCraft arcade. So let's get right to it. The first thing I want to do is show you a startup program that's pretty cool, I think. So let me go terminate the server here. And I have a disk connected to all three computers, and I put a label on it, and the label is Connect4. And then I copied the disk using NEI, and I put it in all three of my computers. I'm not sure if you can do this in survival. I think actually I don't think you can. But in creative, it makes it really easy, because now all three computers have access to the same code. And so if I look at this, the disk has a startup program, the GPU API, which I copy onto the server, so it can know how to draw onto the CCGPU monitors. And it has the Connect4, which is the client application, and the C4S, which is the server application. And what I do is, if you look at the startup program, I delete Connect4 GPSU API if it's already there, just so we don't get errors when we try and copy these. And I'm going to go ahead and get the computer label of the current computer. And if it's the Connect4 server, then I'm going to copy the server program and the GPU API program. And I'm going to call it just Connect4 and GPU API. If it's not the server, then it must be a client, so I'm going to copy the client program, which is called Connect4, and I'm also going to write it as Connect4. So then I can just do shell.run Connect4, and if I'm on the server, it'll run the server program. If I'm on the client, it'll run the client. I think that's really cool, because then all I have to do is reboot it. I don't have to worry about juggling multiple disks. Again, if you're in the survival world or on a server, might not be available, because I don't think you can copy disks with the same label. You might be able set the same label on the different disks. You guys can try that out and see if it breaks your world. I don't want to try that right now. But anyway, so that's my startup program. And then let's look at the server next. Okay, so I just have a print statement at the top, just so I know that the startup code's working, that it knows it's the server. So first thing first, if I am the server, I need to load that API on there, called the GPU API, and then I'm going to set up some code. If you haven't used the GPU API code, you can, or add-on before, you can ignore this. But basically, this is just, it generates the code that it needs to know how to draw a circle. So I just specify the center position, 6464, the width or the radius of the circle, or I think that might be diameter, and the color. So red gets 100 because it's RGB, blue gets 001. So now I know how to draw a red and a blue chip. I also store a table with the number of chips in each column, and that starts out at 0 for each column. And drop time is used to animate the chips as they fall, so I'm using a ½ second. CCGPU does not do well if you try and draw on a ton of different monitors without any sleep time in between. So if you try and replicate this, you need to have a sleep time in between drawing to different monitors. and so I'm using half a second, so it works really nice. I don't get any errors with the CC GPU, and it makes it look like it's animated. So double bonus there. And then I'm going to store the IDs of the server, the red client and the blue client. Okay, before I go any further into this, let me show you how the rest of it is set up. I have a modem on the left of the server and a GPU peripheral on the back. And these are all CC GPU monitors. They're not regular ComputerCraft monitors. These are the special ones called graphics monitors. And you notice each of these have a frequency and a monitor ID. I covered this in a previous tutorial, but if you see, this is 1, 1, 1, 2, 1, 3, 1, 4, 5, 6, and then if you go across, it goes back up to 7, 8, 9, 10, 11, 12, 13 through 18, 19 through 24, etc. So you got to get all the way over to 42. So that way I can draw on each monitor individually. I'm not so sure what the maxed monitor ID is. I've clicked on this to get up to 99. I wouldn't advise doing this unless you have a really good index finger, because clicking all of these the appropriate number of times was not fun, especially 42 and 41, all this row. But anyway, let's get back to the server code. Okay, so you can see I have some helper functions to help me know how to draw a chip at a certain position. So X is going to be the column, Y will be the row, and the color is either red or blue. So basically then I go check, okay, well, do you want me to draw a red one? Then the code I want to use is the red chip code, which was up here. Else it's the blue chip code. Okay, then I do the GPU API draw frame. Now that's how you output code to a monitor. So that's drawing a frame. And the back is where my GPU peripheral is. And then I convert the X and Y to the monitor value. So remember, X was the column. So the first column is actually 0, so I need to subtract 1. So if we give it X equals 1, meaning the first column must go to the 0. Times it by 6, and then add Y. So if we specify 1, 1, we would get 1 minus 1 is 0, times 6 is 0, plus Y is 1. So 1, 1 would draw the top left. There we go. Okay, now if I specify the 7th column, 6th row, you can see that would do 7 minus 1 is 6, times 6 is 36, plus, what did I say? 6th row, yeah, so it's 42. Perfect. So that's how it converts from X and Y, column and rows, to the actual monitor that you need to draw on. Okay, I've got another function to draw a blank screen, and that's really easy. You just do the same thing, you draw it in the same location, the code is the same, but you just pass empty string for the code, and that'll blank out a monitor, a color monitor. The next one I've got is a drop chip, and that one I just specify a column and a color. And because in Connect4 you don't get to specify the row, you just specify the column and it drops to the bottom row, whatever's not occupied. So that's all we get to do, is specify which column we want to drop it in. And first I'm going to take that table. Remember above we had table was all zeros at the beginning, and I'm going to get the current chip count so for this column, and store that in a variable called I. So for now it's 0, right? If there's already 6 chips in there, I can't put any more, so it's just going to return. I should probably return false here so that they know it's an error, but I'm going to assume the players know how to play and don't try and put it in the wrong place. And if they do, they lose a turn, I guess. And then if it has room, then I'm going to do a for loop. And the reason I do a for loop is because I'm going to animate it. So first I want to draw it in the top row, and then clear it. Drop it in the second row, clear it, third row, clear it, fourth row, clear it, until it reaches a spot where there's where it gets to I. There's 6 minus I. So when I is 0, it would do for Y equals 1 to 6. But if I has 5 chips already in that column, it would do from 1 to 1, and it would only draw it in the top. Drop the chip in the top row. Okay, so then I can draw the chip in the column that we specified, the Y that we're doing in the for loop, in the same color I just pass on. And here's where that sleep is. Really important with CCGPI. If you take this out and you try and draw, really, really fast, it screws up and it draws it on random monitors and you get colors everywhere. It's really kind of psychedelic, but yeah, so I sleep for half a second. And then I'm going to, as long as it's not the previous row, because if you'll notice, this one is 7, and this one down here is 6. Now I don't want to drop it down when it reaches its final destination. I don't want to. Let me try to explain that again. When I drop a chip down, I place it in the first row, then basically delete it. Place it in the second row, delete it. Once it reaches its final resting spot, which is 6 minus the number of chips in there, then I don't want to blank it out anymore. So that's why I use the not equals. So as long as it's not in its final resting spot, go ahead and draw a blank. And then it will keep doing the for loop. Okay? And then I go ahead and increment the number of chips in that column. Okay, now we get into the server client code, and this is something I've really never covered before. I've done some RedNet, but this is kind of some new stuff where I'm saying here's a server waiting for clients, and this is really cool stuff. So first I'm going to get the ID of the server and save that, and then I'm going to set a Boolean value called waiting to true and open the modem, which is on the left side. I'll do a while loop while waiting is true, and so right now it's true. It means it's waiting for the clients to connect. I'm going to just print out a message, broadcast out to everyone in range that the server is now online. Okay, and then I'm going to once I broadcast a message, I'm going to go ahead and see if any clients respond. So I'll do a rednet.receive and wait for 5 seconds. That 5 is just a timeout saying you've got 5 seconds to get back to me. If the message comes back and it's from the red client, then I store the ID that came back and I just print out a message saying that red connected. If the blue client replied blue, then I store the ID and print blue connected. Now if I know the client ID and the blue client ID, they're both not null, then I don't need to wait anymore. So set wait to false and say both clients connected. Otherwise, I just end the while loop and it'll repeat because waiting is still true, and it'll go back up and broadcast again. Server's online, see if it gets a response. Okay, so now I have some fun little programs that I was just testing with. Fill random, all it does is it generates random columns 1 through 7, and for 20 chips drops 1 in the red, 1 in the blue in random locations. Fill screen drops a red and a blue in every single slot just to fill it up. That was just so I can test that all the monitors were set to the right ID and that the animation code worked. And here's the actual main function. The first thing the server does is it waits for the clients to connect. Once the clients have both connected, it does an infinite loop, and it will do open the left. Probably don't need to do this because it's already open, but just in case, I'll open the left side modem, and I'm going to send out, say, red, you get to go first. So I know the red client ID from when he replied, and I'm going to say it's red's turn. And then I'm going to do another loop here, and I'm going to just receive for 5 seconds. And if I get a message back and the sender is equal to red client ID, so if blue tries to send me a thing while it's waiting for red, nothing's going to happen. But if red sends something back, then I can say, okay, you sent something back, I want to drop a chip. Red is going to send back the column it wants to drop the chip at, but that's a string, so I need to convert it to a number, and then put it in the red slot. Rain, go away. Or drop in the red color, drop a chip. And then we can break out of this infinite loop because now we know that it's red's turn is over. And then we go ahead and do the same thing for blue. And I could probably put this in a function because the code's almost identical except for just changing red to blue. So while true, again we're doing a loop, go ahead and send out that wait for a message to come back from blue. And if it is blue, drop the chip in the specified column and color it blue. Break out of blue's turn. And then that will just go on forever. And you can see here it actually runs the main, is the actual code that it runs, the start program. Okay, that's the server code. let's go look at the clients. And actually, I don't even have to go to the clients because that disk is here. Okay, so I print out I'm a client just to make sure that's working, and the local variables I have is the actual color of the client, the ID of the server computer, and whether I want computers to play. So you'll saw in my subscriber special that I had at the beginning red comp was false and blue comp was true, so that's like a one-player game. If you set these both to true, the computers play against each other, and if you set them both to false, then you get a two-player game. Probably need a menu on the server where you can say I want to start a new game, 2 players, and then it would send out to the clients if they're computers or not. But yeah, this works for now for my purposes of showing how the Connect4 program works. Since I'm always on a single player, I probably just do true and false for red and blue. The computer player, it's not smart. All it does is pick a random column and drop one. So I'm not claiming to be an AI programmer that it can make blue smart and know where to place chips to block you and to try and win. So the playability of this game with one player is not the best because you can win easily. 2-player game, obviously, you both got brains, you both figure it out. The first thing I do is I get the color of the client, and that's all I have to do is just get the label. So you'll see that the label of this computer, terminate them, is C4 red. And this should be C4, black. Because originally I was going to do black, and then I'm like, wait a minute. I can't do black chips on a black screen. So this is actually called black, but draws blue chips. Oh well. So anyway, if it's equal to C4 red, then I know it's the red computer. If it's equal to not equal to C4 red, I know it's the blue computer. What this does is I just have one program that works for either player. The red player it works for, the blue player it works for. So if you can't duplicate disks like this, like I did, you could just take this one out, go put it in the other client, go put it in the other client, and then start them up individually. Or put it in the server first, then each client. And yeah, so that would work fine. But yeah, so one client application works for both red and blue players. Okay, then after I get the color, I'm going to go ahead and wait for the server to come online. So while the server ID is null, I'm going to open the top modem, that's where the modem is on the clients, and I'm going to go ahead and receive a message for 5 seconds. If a message comes in and it's from the server, that's what the server broadcast, if you remember, it just sends a server, then I know I can save the server ID and I can broadcast back to it my ID. So I'm going to say redness send to the server my color, and now the server knows the ID of each of the red player or the blue player. Okay, so now it knows, and now what it does is it waits for a turn. And so this is an infinite loop again, and it's going to open the top modem and it's going to receive for 5 seconds, same sort of code. And if it comes back with a message from the server saying it's the red's turn, and the player color that it sends back, it says red's turn, and this code is operating on the red client, then it knows it's the red's turn. First, it's going to see if we want this turn to be played by a computer. If not, it'll do a human turn. If else, it'll do a computer turn. And then, if this code is running on the blue computer and the server sends, okay, it's blue's turn, then it'll check either run a human player or a computer player's turn. Okay. Now here's the actual turn. I set a value done equal to false. We're going to set that one true once the turn is over. Clear the monitor, set the cursor position to the top left, and say red player, or whatever current player, it's your turn. Please enter column 1 to 7. And I'll read in the input. And the first thing I'm going to do is make sure they put a valid column in, because that can break your code if you try and send in wrong things. It could crash the server, or if I put A, what's the server going to do? I don't know where to put your chip. So the first thing I'm going to do is take the input, convert it to a number. Might want to put a try catch or something around there, because if they put A, it can't convert to a number, it would fail. This client would crash. But anyway, It converts it to a number and makes sure it's at least 1 and less than 7. There you go, less than 7, because that's how wide our columns are. And if it's valid, they entered a valid value, 1 to 7, then we go ahead and send it to the server, so that's the server ID and what they sent. And that's a string again. Remember, we convert it to an integer later. And we said done equal to true. If they gave us a wrong value, we'll say invalid column, and we'll end, and because we're in a infinite or a loop, be done will still be false, so it'll just loop again, asking them for their turn again. I just realized I clear. Yeah, this won't work because it'll do print the invalid column and then immediately clear the screen, so they won't know that their turn they specified invalid column. Oh well. Okay. After their turn is done, so it exits this while loop, it'll clear the terminal again, set the mouse position back up to the top left, and say waiting for opponent to take a turn. And so then it'll just wait until it'll go back to the waiting for turn code, and it'll run forever like that. So it'll give you a red turn, black turn. Here's the actual function to call: is get my color, wait for server, wait for turn. There's no check for win condition. The server should probably win that or run that code to see, okay, if one player has 4 in a row. I don't have that in there yet. That code's a little bit more complicated because I have to store a table with what color is in each thing and compare, and I might do that in a part 2 or an extended version of this, but I wanted to get this game out so you guys could see it. That's pretty much it. If you want to see it being played, just go, well, let's play a quick little game against the computer because we can beat him real quick. So let's go page up here and let's make the blue computer true. Save, exit, reboot the server. Control R does a reboot. Reboot blue client, just make sure it got a message. Okay. Oops, that's the disk drive. Perfect. Both clients connected, and it should be Red's turn. Okay guys, where do you want to put it? Let's put it right in the middle. And as soon as it gets down, Blue's going to place it in there. Ooh, good move, Blue. But I'm going to put it right on top of you. Blue's going over there, huh? Interesting move. Let's put it on. Let's block his and go in the middle again. Uh-oh, he's starting to build up a line there. So we better put one to block him. Okay, where are we going now? I think we're going back in the middle. We might be able to win if it doesn't choose the right column. Ah, haha, we've defeated you, Blue. And again, there's no win condition. This could just go on forever. You know, again, you could just keep playing. Even though we've won, the game will keep going on. So, that's Connect4. Hope you guys enjoyed. Again, about my channel, I have a Twitch stream. Go on there. It has a chip-in link. If you donate anything at all, a penny, whatever the minimum PayPal chip-in donation is, anything at all, I will send the email that I give the donation for, all the code, a link to Pastebin of all the code for all my ComputerCraft tutorials. So if you guys want that, it's just help my stream out a little bit, help my channel out a little bit, and because I need to get a better, I need to get XSplit, and I need to get a better mic, and eventually a better computer. That's a long-term goal, but yeah, so if you want the code and you want to support my channel, go donate on Twitch. There's a chip-in link. The other way you can donate is at the Twitch TV, down at the very bottom of my channel, there's a link to buy video games from a website, and I just have a referral code on there. And so if you buy something, you get 5% off, and then I get, I think, 5% as well as an affiliate. So that supports the stream as well. If you don't have money, don't worry about it. You can watch the video to get the code. I'm not going to hide it. And just by watching this video, you're supporting my channel. So I appreciate it. Thank you guys. I hope you guys enjoyed this tutorial. It kind of covered the CCGPU API as well, again, and some client server stuff and some cool startup programs that you can use. And hope you guys learned something. If you have more suggestions for tutorials you want in the future, again, comment in the in YouTube. And that's about it. So this has been FunshineX. I will see you guys later. Bye.